क्या भाई, good afternoon. Recording has started, no? Just wait few minutes. I'm not starting. Why you started recording? Good afternoon.
Good afternoon, sir.
Good afternoon, sir.
Good afternoon. Okay, so lab experiments of the day is based on our learnings in theory classes to water measurement, a measurement of water. So what methods have we learned? Irrigation water measurement. Our irrigation water can be supplied through open channels as well as underground pipelines, pressurized system. So if recall, in both the conditions, we need to learn how to measure the water. So first, today's lab is open channel flow measurement, how to measure the discharge. So if you recall, we tried to understand the flow method, that is one way in channels, open channels, either it's a natural channel or it's irrigation channel. Then current meter we can use to measure the velocity to find out discharge by using the mass conservation principle. Q is equal to area into velocity, discharge is equal to area into velocity. And another way, that is discharge measurement through another property, could be by using weirs and notches, flumes, orifice, and so on. Pitted tube as well, it is used in both the conditions, open channel as well as pipe flow system. So the learning here is about weirs and notches. So I have given you one write-up. Have you gone through that? I need answer at least from
Yes,
what. Yeah. So is it clear, the principle? Theory is clear? Have you gone through that?
yes, sir.
Yes, sir.
If I believe that you have gone through that, then let me once more summarize what does that mean through this PPT I have prepared for you. Can you see the PPT? The study of
Yes, sir.
weirs and notches. So you know what is weir and what is notch, what is basic difference. Notches are made of metallic sheet. Weirs could be of anything, wood, metal, or masonry, concrete, whatever it is. But it is for more precise and smaller water measurement, that is diverted to agricultural fields for irrigation purpose. And there are three types of notches: rectangular, triangular, and trapezoidal. We have learned in theory. So here the objective for the day or today's lab is learn about rectangular and triangular weirs. So it's basically called the calibration. We can say calibration of rectangular and triangular weirs. What is calibration basically? Anybody? What is calibration? How to define calibration? Anybody? No one is speaking. What happened? Calibration is basically developing a relationship between known and unknown condition in very simple word. We know one thing, an unknown condition is linked with the known condition. So we can have a kind of relationship between known and unknown. And if we are making a graphical relationship, suppose this is X quantity which is known. and its y that is unknown. Any relationship suppose we have developed, we know the known condition. Suppose here is the head. For simple example here in weirs and notches, we can measure the head. So if we have measured the head that is x, we can know the unknown condition that is discharge for us from this relationship. So this is suppose discharge versus head, we can have a relationship. This is calibration relationship, calibration curve. So calibration of rectangular and triangular weirs. If you recall theoretical equation we have learned, say for rectangular, discharge is equal to 2/3 or 3/2. CD root 2G L H. How much? Anybody?
3/2.
3/2. And what about triangular notch? Discharge is equal to, we have learned 8/15 CD root 2G L or not L? L is there or it's a no L?
No L, sir.
Okay, then tan
H4.
theta by 2. H to the power 5/2. These are the theoretical relationship we have learned between discharge, length of the crest that is in rectangular weir, and head over the crest that is H we have learned. G is known condition. So if we have a weir, we can install in any channel. Suppose it's a channel here, rectangular channel suppose. So we can install a weir here, suppose here rectangular weir, to measure the flow simply downward. This weir we can install here and we can measure. But important aspect of learning is we can install the weir. We know theoretically that discharge could be like this 2/3 CD root 2G L. We know the L because we can measure the length of the crest. We can measure the head over the crest of water, suppose here, that is H. However, we don't know the CD, coefficient of discharge. It depends on the flow characteristics and weir characteristics itself. So first time it is important to find out the value of CD. Once we know the value of CD for any of the weir, whether it is triangular weir, whether it is rectangular weir, if we know the value of CD, we can use the head measurement, that is H in both the cases, to find out the discharge. So it's important to estimate the value of CD of any of the weir, whether it's a triangular weir, whether it's a rectangular weir. So we can say the objectives of learning today are to calibrate rectangular and triangular weir, means to make a relationship between head and discharge from the observations. Simple, two observations, head versus discharge, we need to observe. So make the relationship, that could be a kind of calibration. Then if suppose we are trying to install first time a weir, it is important to understand the value or to know the value of CD, coefficient of discharge. So from these two are the same two observations, head versus discharge. Find out the value of CD for the weir. How we can do that? We know the relationship. So number of observations if we are taking by changing the discharge, we are measuring the discharge because it's observation. So for taking Q1, Q2 conditions, CD is constant for the weir. It will not change theoretically. Only it will be the head H1 and H2. So it will be discharge Q1. So head will be H1. Discharge will be Q2 or changed condition, then head will automatically change. If we have these two conditions, we can find out the value of, say, CD for all the observations, because we know the observations for discharge We know the head, we have measured. We know the value of G, we know the angle theta for this suppose triangular weir. We know the value of L, length of the weir, rectangular weir. So we can estimate or we can calculate the value of CD for all the observations. Suppose n number of observations we have taken. And for all n number of observations, it should be theoretically the same CD value. However, there are a lot of error and value of CD may change. So for all observations, if we are taking the average CD, it could be the more correct or accurate value of CD for these two weirs. Now you have already learned, or we have also learned, that Francis formula, first it was developed. Discharge is related to any of the weir as CLH to the power m. Or say simply it was developed by Francis by condition that discharge is proportional to the head to a particular power m. And then in that way, it is equality condition by using a constant that is C, and length of the flow is also proportional to the discharge. So in that case, by using the Francis formula, or in Francis formula, there are two terms, C as a constant, which should be a practical value if we are installing this weir in the field or in the channels, and this slope value or exponent value m. So for each observation, Q1, H1, Q2, H2, we can find out, or we need to use these information or these observation to find out the practical value of these weirs, two weirs, the practical value of C and M. This is the next two objectives of our learning. So how can we do that? We have Q1, C is constant, L is same, H1 is there, and M is constant. So if we have two observations, Q1 and Q2, CLH2 to the power M, if we divide simply Q1 by Q2, that will be equal to H1 by H2 to the power M. And by using this relation, we can find out, because Q1 and Q2 two observations we have for respective H1 and H2 two heads. So we can find out the value of, or say practical value of M here. And once we have the practical value of M, from the same relationship, Q is equal to C L H to the power M. By knowing the value of M, we can find out the value of C here. So this is the learning we need to perform today. So we will have a weir assembly with flowing water arrangement in the channel with rectangular and triangular notches there. It will be water supply to the pool of water or to the channel with the storage tank will be there. There will be, suppose it's a flowing, or we are taking simply observations flowing out from this notch. So Q discharge can be measured by using a bucket and time arrangement. Or say simply this is a bucket. We are measuring this discharge from here, say for time t. T is equal to maybe 20 seconds or 30 seconds. And we know the volume of this tank because we know the length, width, and height of the water that has collected in this bucket in particular time. So we can find out what is the volume of this water, LVH, and divided by time if we are doing, it will be simply discharge in cubic meter per second. Whatever unit or length or dimension of this tank or bucket is, we need to convert in meter. So it will be in cubic meter per second. So it will be graduated storage tank. In practical, you will see in the video that there is a tank which has a kind of stilling basin, means it is having an outlet, and it has a tube to measure the height, accurate height of water in this tank, and it is calibrated in terms of liters. So liter, if you are dividing by 1000, it will become to cubic meter. So there is a graduated tank to get water collected, that is discharged from the weirs. So there are arrangement. There is supply pipe which is collecting water, and once you have say observation time over, you can shift this supply to outside so that it is not getting affected, and you will know the discharge. For time, anything you can use, your mobile, stopwatch, and hook gauge. I told you in theory class that to measure the level of water, suppose here we need to measure, it is not good idea to use a gauge which has a pointer like this, because once it is touching, it will go a little bit inside the water level. That is characteristics of water. But here to measure the level of water, there is a hook kind of gauge there, which is coming, our tip of this gauge is coming exactly at the level of water from down inside the water itself. So there is a hook gauge to measure the level of water in the tank or in the stilling basin by using vernier scale. It is vernier scale mounted hook gauge measurement of water. Now you have gone through the theory. I assume that I have supplied, and theory classes also we learned that how to measure the discharge from weirs, how to estimate. So this is Francis formula. You know that discharge is proportional to head to the power m, and in equality condition discharge is equal to C, that is a coefficient depending on the nature of crest and approach condition of the flow. L is the length of the crest if it is a rectangular weir, and h is the head over the crest, and m is one exponent. That again depends on the weir opening, whether it is rectangular, triangular, or trapezoidal. So this is for triangular weir, Francis formula, and this is for rectangular weir, and this is for triangular weir. Now, in methodology, if suppose we need to arrange everything, you will see in video it is not much detailed, but if you are doing, you need to put this whole assembly in the system of water supply. There is a frame where you can put the V notch, or it is rectangular notch. You can fit here at the outlet of the channel. There is a frame. You need to tight it. You need to know what is the angle here, what are the dimension, length of the crest, and we need to measure head over the crest. So important aspects are when we are supplying water. If you recall your theory learning, that measurement of head should be at least 4h upstream side of water. So suppose h is the head that we are going to measure, at least 4h upstream side we need to measure the head. Reason being, the flow characteristics goes like this, it will reduce here at the head. So that's why we are measuring somewhere here, head. Second aspect is this channel is something like here, it's a channel, and then it's again, so water is coming somewhere here and it is going like in this way. So everywhere we use baffle plates. Baffle plates are simply plates which are having holes here to allow the water pass through it, so that any eddy or disturbance in water current is removed, and the moment water is reaching to the weirs, it is free from any velocity. It's just push flow kind of condition. So it is just pooled here. This is a pool of water, and because of gravity and opening here, it is coming with almost zero approach velocity. Once these conditions are existing there, we can go for measurement of discharge for different head condition in both the weirs. So say suppose first Q1 discharge, then Q2 discharge, and at least for each of the discharge there should be 3 observations, so that it is more accurate observation once we are summing up the results. So in this way, this is the observation table you have already seen in the write-up I sent to you. Length of the rectangular weir, that is, I think it's 12 centimeter. It will be available in your observation sheet. And angle of V notch or triangular notch, 2 theta is 90 degree. 2 theta means this is 2 theta here. So what we need to do, we need to, once we have started observations, water is coming from this side, level of water, initially the 0 level we are not measuring. We have started observations from a particular head here, suppose H. So once all these observations Q1, Q2, Q3 are finished, we stop the supply of water, and when the water is almost 0 here over the crest, we are measuring the head of water, that is equivalent to the level of this crest. If you are taking first, water is coming as a stream here, it will give you the wrong information initially if you are taking the head over the crest of water. So usually 0 level or level of the crest is taken at the last when water supply is stopped and all the excess water over the crest is removed or it is passed by. So in this way, we are taking the observation initial hook gauge reading when we are starting, say, observing discharge for 30 seconds. Then second hook gauge reading means from where it has started. So head difference between, suppose initially head was here, second we have increased to this level, so difference in head, and that head basically, sorry, it is taken from here, from the crest. So what is the crest head and head Q1, Q2, whatever it is, we are taking here. So difference between these two heads is simple the head difference that we are taking, that is H, and then volume of water that has passed in certain time T, we are recording in a storage tank. So time taken, this is the total volume, this is the time taken, we can calculate the discharge, and in that way we can find out the value of coefficient C, CD and M. What is our learning for the day? And also at the same time we need to find out a relationship. Here it is given Q versus H 3/2 for rectangular notch and discharge versus H to the power 5/2 for triangular notch. However, you can also plot Q versus simply H for triangular and rectangular notches. This relationship can be in any unit. It has no meaning. So discharge you can take in liters per second or cubic meter, whatever you like, cubic meter per second. And H you can take in centimeter or meter, whatever you like, but it's a simple relationship. That is called the calibration plot. So that in future for the same weir, if you are using in the field, you need to just record the head in the same unit and you will immediately get the information about the discharge, whether it's in cubic meter per second or it's in liter per second. And then by simply multiplying the time, you can find out what is the total volume of water it has passed or it has diverted to the field. To calculate the value of CD, you can use the theoretical relationship Q is equal to CD root 2G LS 3/2 and 2/3 here for rectangular, and the relationship you have already learned for rectangular, sorry, it is rectangular and triangular 8/15. So you can estimate the value of CD for each observation and then average out to find out the average value of coefficient of discharge. Then practical value of M, you can use the subsequent relationship discharge observed in different times with different heads H1 and H2, and you can find out the value of M here. And to estimate the value of C, the whole Francis relationship Q is equal to C LH to the power M can be used. So C will be simply equal to the Q divided by LH to the power M. M you have learned from here, you know the H, you know the L, so you can find out what will be the value of C. So average value of C, M and CD you can find out. So this is whole learning. There are some precautions you have, I hope you have already gone through it. And this is how it looks like. This is V notch side view. You can see, or this is in practical, how it is installed to measure the head over the crest. Finally, that is used to measure the total amount of water that has passed. And this is the simple idea of a trapezoidal, that is rectangular. Rectangular I am writing, but it's a trapezoidal a little bit. It has slope from the vertical. So if it is vertical, it is simply rectangular notch, sorry, here, right? So if you have any query in this, because you have already gone through theory, so I hope there will not be any query. Anybody? Anybody? I'm not listening. Any answer? Do you have any question? Query related to this?
No, sir.
Okay. If no, then there is one file. You just go through it. One video that is available in your file section. Class material, and that is experiment 5. It's a video. Experiment 5, Weirs and notches. It is, I think, near about. Have you seen this video? Downloaded this? Can you check this in file section? I have uploaded there.
Yes, sir. It is there in file section.
Okay.
Yes, sir.
So it's working. Can you watch this?
Yes, sir.
Okay. How much time it is? For how much time?
Minutes 21 seconds.
How many minutes?
12.5 minutes about.
12.5 minutes. So it's just 3:02. So let us meet at 3:15. Okay. Just watch this video and come with your queries. And then I will give you observations for these two weirs. In the video, I think it is just one for your understanding how it works. And observations I will give you for rectangular and triangular weirs. So you need to learn the process. Watching this video and doing analysis or calculation for observations for discharge and head. So let us meet at 3:50 or 3 near about 16, 17 or 20. Okay?
Okay.
Okay. You can ask me anything in between if you have any query or it's difficult, though I feel that it will not be any difficult because you have already gone through the theory classes, a theory of this particular line. these are the notches. You can see this is triangular notch of 8 centimeter height with opening of 90 degree. We have another angle notch, as you can see here, it is 60 degree V notch, 12 centimeter height, and we have this rectangular notch of 12 centimeter size. So we can put these notches here by using this nut and bolts arrangement, just like here. We can put it here, and then put this and tighten this so that it is fixed here. Okay, and water is coming from this behind surface here. Once water is passing over this crust, it is collected in this and going to a tank which has a measuring arrangement at the last by using Stirling basin principle, and this head of water is measured, which is directly calibrated in terms of liter of water. We have this arrangement, and to measure precisely for 30 seconds, 1 minute or 2 minutes, we will remove this and another. So in this manner we are simply collecting the discharge over the crust to this tank. Now let me show you how the head is measured over this crust and where it is measured. As I told in the class, at least 4H behind the crust we need to measure the head, and how the water is supplied so that it is passing over this crest. Let me show you. So this is arrangement. There is a sump which is supplying water by using the pump, and pump is supplying water to this point, suppose. So these are the waffle plates we have in this. You can see waffle plates. It has openings so that the turbulence of water is removed through passing from number of openings. And why it is in this arrangement? It is going in groove so that any turbulence in maximum form it is removed, and the moment water is reaching to this notch, the approach velocity is almost zero. We cannot say exactly zero, but it should be like a pool and water is just flowing off from this point. Then head is measured, as I told in the class. From this crust we are measuring head, but you have seen the shape of this nappy will be slowly reducing. So exact head we are measuring at least 4H behind this crest. So this is the point near about 20 centimeter. We can have 5 centimeter head over the crest. So we are measuring here the head by using a kind of Stirling basin. So we have here water. Let me show you from this side how it is. Now you can see we have just here a hook gauge. There is a hook. Water is going to this basin or Stirling basin or this compartment, which is equal to this chamber. So it is working on the principle of vernier scale. So we have main scale, then vernier scale, that you know, and we can measure the precisely the head of water that is causing the flow over this crest. So let us see in practical how it is really working, and I will give you the observation to find out the right answer. What is the amount of water that is passing over this crest at a certain head, and also you need to find out what is the practical value of coefficient of discharge CD, in general equation C, and the value of M, practical value of M. So practical value of C, M, and coefficient of discharge of any of these two notches you will find out. You can see water has filled up to the level over the crest. So it started coming out over the crest, and it is called the nappy. Nappy should be very clear, means no touching at the bottom. Now, once we are interested to measure the value, we will shift this to measuring point, right? And this is the basically idea of baffle plates. Now you can see water is coming out, it is disturbed water, there is turbulence. The moment it is passing through baffle plates here, water has least disturbances. Now it is going to this outflow chamber, and you can see here level is reduced. However, this flow is occurred because of a level which is much higher from this particular point. So we are measuring at least 4H away from the crest, the head of water, which is causing flow. And flow is measured by using a hook gauge. You can see we have a hook here. I will show you by putting the camera from that side. Hook is there, you just see it's a hook above the water. Now it is going, so this is the point where water is just touching the tip of the hook, and we can read what is the scale in this. It is now stabilized the head of water which is flowing over the crest. So we need to measure what is the head. But at the tip, at the last, means tip, level of the water at the tip are just over the crest. We will measure at the last when we are going to finish this experiment. So let us find out this flow is occurring. You can see the nappy is very clear. So it is going down to collection tank, and from collection tank we can find out what is the volume of water that is passing over this crest per unit time. So now this is very much stabilized head of water. You can see here the scale. This is hook gauge. So tip of hook is just at the level of water, and scale you can read from the main scale and vernier scale. So main scale reading it is 12.9, and in vernier scale you can see the 8th division is matching properly. So it is 12.98, the head of water. But we need to find out what is the reference over this 12.98 is. So we will find out at the last. Let us see how much water it is delivering per unit time over this crest. You can see it is at exactly 55 liters. So let us start for 30 seconds observation. Say for 30 seconds how much it is going. Let us find out. $28, $29, and now $30. So it is somewhere 174 liters. So let us start from 80. Now it is 80. Let us start. So go from 200. Exactly when it is 200 liters, from 80 to 180, sorry, it is 180 to 200, we will find out how much time it is taking to go 20 liters of water over the crest. That will be the discharge rate. So let me see how much time it will take to reach 200. From 180 to 200. So now it is 41.40. So from, let us again take from 210 to say 30 liters. So we will see starting from 210. Yeah, it is. So 210 to, let us go 230. So 20 liter again. Let us see how much time it will take. It is 2:25, reaching to 2:30 now, 40.68 seconds. So in this way, we can find out for different head conditions what is the rate of flow, that is discharge Q. Once we have Q measured, we can find out what is the value of coefficient of discharge of this particular notch. Here we have first put triangular notch by using the equation 8/15 CD root 2G something, and then by using the standard common formula for notches, we can find out the practical value of C and M. So let us take observations for another heads. And okay, so you can see it is zero flow condition now. So we can read from the main scale and vernier scale. So in main scale reading is 9.3, and you can see which of the vernier scale is matching with the main scale, that is 8th. So it is 9.38 is the reference head over the crest we have measured. So if we are taking the difference between these two, 9.38, and the first we have taken 12.98, then that is the head over the crest because of which the flow has occurred. And flow observations we have taken in liters, that is Q. So you can find out by using the equation CD as well as practical value of C and M. Then you can go for calculation or learning of discharge capacity of these two weirs, triangular and rectangular, by using the observation. Thank you. Yes. Have you finished? Did you finish watching video?
Sir. Just finished. Yes, sir.
Any query?
Sir, how did you measure the level of water in storage tank?
Storage
because
tank.
the measurements were taken from outside, but the water is inside. Like, how did you?
It's basically, that's why I told. Let me share. That's why I told. Can you see the PPT?
Yes, sir.
How it is coming? There is a tank basically. Is not that?
Yes,
and
sir.
Tank is connected with a tube here.
Yes, sir. The tube was not visible properly. That's why.
That's why its tube is connected here at the bottom here. So the moment water is diverted here, this tube is graduated and it is calibrated basically.
Yes,
Means like here up to this level, if this is the water, this is suppose a number in this tube, this is called the stilling basin. Both sides it's a stilling basin. You are measuring the head that is coming through channel, passing over the crest, that is also a stilling basin. There is connected somewhere and there is a big reservoir kind of a stilling basin, but here it is simple tube stilling basin. Water level is same and it is well calibrated that if this is the level, this is the amount of water in this. So suppose this is the level, suppose 12 centimeter height from bottom, it's 40 liters. It's a simple calibrated in liters. 40 liters means 40 divided by simply 1000. You can make 0.04 cubic meter. Is not it?
Yes,
so
sir.
this is in collection tank. or you can put any. It's a basically volumetric measurement of water. That also be discussed. Coming through a siphon, you put a tank, whether it's a graduated or you can use liter or any other measuring unit, or simple dimension of this means reservoir length, width and height in centimeter will give you cubic centimeter of collected water in a particular time t. So this is a stilling basin kind of arrangement to get the discharge measurement. Any other query? Any other question? Should I assume that there is no query, no question? Okay, so you just see there is observation table available in your class material folder. Experiment 5, Weirs and notches, observations. That is in a Word file. Can you see that?
Yes.
Is it available? Right? So there are observations for triangular notch and second table is rectangular notch. So it's a 90-degree V notch we have used, and H0 is the initial gauge reading, means at 0 level when water was exactly at the tip of V notch. So it was 9.28. And who gauge as different heads, H1, H2 means we have observed 5 times. So it was for different heads, discharge was measured in volume, in measuring tank or storage tank, in liters. For a particular time t is recorded here, right? So you can find out the discharge, then calculate the value of CD, C and M for practical conditions, and results must be in 4 aspects: a calibration curve between discharge and head, value of CD, coefficient of discharge from theoretical question or formula we have derived, and from Francis formula the practical value of C and M for these 2 notches. Is it clear?
Yes.
Observation tables are clear? Any query? Any question if you have?
Sir, can we use transparent glass tank to collect the water and
Tra
have it
transparent?
transparent glass tube?
To collect the water or to measure the head? Means
Sir, and storage as a storage tank, can we use it?
I couldn't understand your question. Means you are simply telling that we have a transparent tube that is attached to find out the head of water in collection tank. Is not that?
No, sir. I mean, can we use a glass tank?
Any tank, if it is having sufficient strength to collect that amount of water, any bucket, any tank, whether it's made of glass, whether it's made of steel, you can use it.
Yes, sir.
But it's only the matter of correct measurement.
Yes, sir.
So it's bucket and what it is called stopwatch arrangement, time versus collected volume of water in any tank. So either it's a dimension of the tank, or you can measure by using a simple liter measurement. That is also possible. So it's a volumetric water measurement for a cert that is collected in a particular time t to find out the discharge. Is it clear? That's clear. Students?
Yes, sir. It is clear.
Okay. Now, if you have everything clear, then let me ask Rajesh and Uday. How many students are not submitting records? Or they are not present? Or they are not attending the lab class? Let me declare the names here so that they can take care about their attendance. It's not basically attendance only, but it's a completion of the learning. We need to, or I need to evaluate based on your learning. Rajesh, do you have account?
Yes.
Uday?
Sir, 8 people are not attending. Around means.
Can you announce the name, please? Alphabetically, if it is, then could be better for me.
Buri Rahul, Prajwal Jha,
Rahul is here?
Somesh.
Yeah. Rahul? You are here. I can see your name here. Rahul? Be Rahul. Mark this, that he has joined the Google Teams, Microsoft Teams, but he is not here. Next, Uday, who is next?
Yes, sir. Sir, these are the person who have attended this lecture, but they have not submitted. So,
Okay.
Somesh Harshman also in lab 1
Yes.
he attended and not
Somesh,
submitted.
Yes, sir.
why have you not submitted?
I have sent email ID. So I am checking. So I have
You
sent.
need, if you sent it, you need to forward it so that we can have record that yes, you have submitted, but by chance or by mistake, it has not reached to us. You need to prove it. This is not our job to
Yes,
take
sir.
this.
Yes, sir.
Okay, next.
It may my mistake.
Sir, Muhammad
Muhammad
Abu Faruqi means
Abu Farki.
he is also present means
He is,
in earlier lectures.
oh, but he is not present today.
Yes, sir. But
Mark absent as well. Then
yes,
next.
sir. Nikhil Raj Dhurve.
Or Nikhil Raj Dhurve.
Yes, sir.
Why have you not submitted? You want to say something or you have not submitted simply? What about attendance of Mr. Nikhil? Uday?
Sir, he has attended.
Attended.
Yes, sir.
So, Nikhil,
Yes.
if you are not working to complete the labs, attendance means
Sir,
you
I
have
have
submitted.
done.
Have you submitted?
No, sir.
Why? If there is any problem, you can tell me. We will try to solve it. Maybe because of certain reason you couldn't submit, because it's 4 labs we have completed. This is the 5th one. So what is your answer? Why have you not submitted? You need to speak, please. Nikhil?
Yes, sir. Some personal issue.
Okay. So will you be over very soon to submit the records?
Yes, sir.
Okay, so do it. Do it in this week. Would I mark
Okay,
these conversations as well? Who is next?
Sir, Sandeep Ruhela.
Sandeep?
Sandeep Ruhela.
Sandeep
Sir, he has
Ruhela.
submitted only one lab, the first one.
Sandeep, you are here. For Abe, it is showing Abe. Mark this, that Sandeep has joined but is not present.
Yes.
Who is next?
Next, sir, Jaya Siona MJ.
J.
Yes, sir.
J.
Jaya Siona
Sir,
MJ.
I have not submitted only first lab report.
Yeah.
What about others?
I have
Others,
submitted, sir.
Okay, so you please submit. You were not present, or you have any kind of problem there in
No,
first
sir,
lab?
I just missed the first lab submission deadline.
Okay, so you can submit it now. It will be a
Okay,
little late, but it will be helpful for us.
yes,
Who
sir.
else? Uday?
Sir, one is Divyant LG.
Divyan? He is not here. Mark him absent. I will download attendance and will send you as well.
Yes, sir.
Who else?
Avjad Juman.
Abjad. Abjad is also absent today. Mark him. Next.
Abhilash Mukherjee, sir.
Avilas.
Sir,
Yeah, Avilas.
sir, actually, I missed the deadline of the first lab, so I did not submit it. Other labs I have submitted.
Uday, others are submitted? Other labs are
Yes, sir.
submitted? Okay, then fine. Okay, submit it. Submit
Okay.
the first as well if you can.
Okay, sir. Yeah, sure. Actually, I missed the deadline. That is why I thought it would not be recorded. Okay, sir.
Deadlines means you will not submit it at all.
No, sir. Yes, sir. I'll submit. I'll definitely
Late
submit.
submission has a kind of penalty, but not
Okay.
submission means it's a completely zero.
Okay, got it, sir. Surely, sir. I'll submit.
Anybody else there?
No, sir. These are 8, 9 students.
Rajesh, how many from your side?
Sir, I am Sandeep, sir. I also missed deadline, same as Abhilash.
So far, how many? How many labs?
Sir, just one.
Just one you submit. It will be late.
Okay,
Counted
sir.
as late submission.
Okay, sir.
But no submission means zero.
Sir, I will submit today only.
Do it.
Sandeep,
Rajesh?
I just received one lab from you. Lab 1.
Sandeep, only one.
Sir, I have sent the lab 3, sir. I'll just check once also.
Okay, Rajesh, in your group, how many are?
Sir, only one student have not submitted Google Oath Ritvik.
Google Othu.
Google Oath Ritvik.
Ritvik?
Sir,
Ritvik? G.
sir,
Ritvik? Yeah.
yes, sir. I couldn't submit because there was some problem with me, sir, in the first 2 weeks, and I will submit it this week, sir.
Okay, so you complete the labs, and if you have any problem, you can ask me here.
Yeah, 2 weeks we have got COVID, sir. That was very, so it became severe at the time for me as I'm having asthma and sinus. So right now I'll cope up everything and I'll submit this week.
Okay, no issue. And if you have any other problem, you can discuss here. We will try to help and solve it. Okay. So rest of the students have submitted, right?
Yes, sir.
Okay. Any query, anybody? If there is any problem in learning, understanding, or any confusion, you can ask. No confusion, no query.
Hello, sir.
Yeah, please.
Sir, is it possible for you to extend the deadline for the Saturday night itself? Because Saturday 5 p.m. actually, due to several reasons, we may unable to submit the records. If it is possible for you, then sir, please do the deadline extended by the Saturday night only. That will be beneficial.
How many of you want to get it changed?
Yes, sir. Yes, sir. Same, sir.
Yes,
From
sir.
evening 5 to Saturday,
midnight
what
will be
time?
Yes, sir.
Night 9 o'clock?
12 o'clock, sir.
I guess 12 will fine, sir. 12.
Night 12 o'clock.
Okay, Saturday means full Saturday, 12 o'clock. Uday, it is fine, Rajesh?
Sir, actually all the assignment deadlines are 12 p.m. in Saturday. No? Like we are habitual to submit it late night. That's the point.
You are not
Many of us,
habitual to submit late night. You are habitual to do it at any of the lab or any of the academics at the last. That I know. I am teaching you. You are
Sir,
not teaching me.
we go to play sports and all, na, sir, in the evening. So,
Not every day. That also I know. Have you seen
sir,
me
every
in
day,
Tata
sir.
Sports?
Sir, interval is
sir,
coming.
if possible,
And
please extend it to
No, it's
12.
extended. It's not a problem. But your explanation is not correct. That only I mean to say.
sir, it is correct.
Rest of the things are fine. To change the timing, I have no issue. But explanation, it's not convincing to me. You are more busy in gymkhana activities, that I know, but it's not a sport exactly. Maybe for short period of time now, it may be for few days. But other non-academic activities, but supporting activities, I can say non-academic doesn't mean it's not supporting, it's required and supporting. You are more busy. That I know. Society is here, there. That is fine. So, okay, Saturday, midnight. Is it okay? 12 o'clock Saturday, that must be stamped
Yes, sir.
in your email.
Yes, sir. Thank you, sir.
Okay. So, any other query if you have? No?
Sir, if possible, like there is, can you increase the quality of videos? Video quality.
I have a camera and I use that, and that is start coming of the time. But certainly I will try.
Yes, sir. Yes.
Okay. Okay. Any other query? No? Okay. Then, okay, just to complete this and submit it, right? Okay, then see you.
Thank
Thank you, sir.
Okay, welcome.
Thank you.